Welcome to the new video tutorial from Metacentric Bangladesh in the series Electrical Engineering. This is lecture number 3, current divider rule, or in short we can say CDR. So basically we know that current actually divides in parallel combination or parallel circuits. So here this is a very simple circuit consisting of R1 and R2 resistors in parallel combination. So this is the battery of V volt, and this is the current I which is flowing from positive terminal towards negative terminal. Whenever the current I reaches the point A, it actually divides because it has two paths. So current needs actually paths to flow. So basically at point A there are two paths. One path is going through R1 and another path is going through R2. So the current I, some portion of the current I actually, that is I1, is flowing through R1, and some portion of I, that means I2, that is flowing through R2. And whenever the divided currents I1 and I2 meets point B, they actually merge and become I again. So this is a very simple circuit. So we'll use Ohm's law. According to Ohm's law, the potential difference V is equal to the multiplication of the current and the resistance. So V equals IR, or we can write I equals V by R. Suppose we need to calculate the value of I1 and I2, because this is actually current divider rule. That means this rule can be used to determine the divided current's value or the magnitude. So I1, according to Ohm's law, we can write I1 is equal to V by R1. So what is that V? So basically this is a parallel circuit, right? So the potential between the two terminals, that means in that case A and B, so are basically same for every resistors, because this is a parallel combination or parallel circuits, and these two terminals are common for every resistors. So that means the potential difference are same for all. So according to Ohm's law, in the numerator there should be the potential difference, that means V, or we can write VA minus VB, and in the denominator there should be that resistance, that means R1. So I2, we can write I2 equals V by R2. So we have to calculate the value of V. That means if we have calculated the value of V, then after plugging the value of V in the equation 1, we will get the value of I1, or in equation 2 we will get the value of I2. To calculate the value of V using Ohm's law, we can write V equals IR. Okay. So we can write V equals IR. Here we need to calculate the value of R. R is the total resistance, or we can write equivalent resistance, but we'll use the term total resistance. That means 1 by R, using the parallel combinations law, we can write 1 by R equals 1 by R1 plus 1 by R2. So that means 1 by R means the inverse of the equivalent resistance in parallel circuit is equal to the inverse summation of all the resistance. So we can write, after I have skipped couple of lines, so R equals R1 into R2 divided by R1 plus R2. So this is a shortcut formula for two resistors that are in parallel combination. That is, the multiplication of the two resistors should be placed in numerator, and the addition of the two resistors should be placed in denominator. So plugging the value of R into equation 3, we will get the value of V. So we can write V is equal I into R1 into R2 divided by R1 plus R2. So plug the value of V in equation 1. So we can write from 1, we can write I1 equals, so what is the value of V? In that case, in the new denominator there should be R1. So we will replace the value of V by this. So we can write I into R1 R2 divided by R1 plus R2, right? We have replaced the value of V. So simply we can write R1 into R2 divided by R1 plus R2 into R1 into I. So that R1, I should change the color, right? So R1 and R1 is cancelled. So the formula becomes R2 divided by R1 plus R2 into I. Similarly for equation from equation 2 we can write I2 equals R1 divided by R1 plus R2 into I. In that case, I is the total current. Okay, so if we can generalize the formula, if we want to calculate the value of I of X, then what we have? So basically that formula is, whenever we want to calculate I1, the numerator should be the opposite resistance. That means we are calculating I1, so as numerator the value of the resistance should be R2, that means the opposite resistance. Okay, and divided by the addition of that resistance and total resistance of the opposite side. So in that case we want to calculate the Ix. That means as the numerator there should be R of opposite total divided by R of X plus R of opposite total into total current. So this is the generalized formula for current divider rule. We'll learn something about current divider rule for 3 or more couple of resistors in more couple of resistors soon. So this is the end of the video. I'll upload another video of CDR. Okay, thank you for watching. So welcome to another video that is related to the lecture number 3, current divider rule. So in the previous video we have learned something that is used for current divider rule. That means if we use that generalized formula we can calculate the divided currents. Okay, so now this is the circuits. If you are encountered with a circuit that has more than 2 resistors that are in parallel, what can you do? So how can you solve the CDR formula? So before that there is a side note. To calculate the equivalent resistance for 2 resistors which are in parallel combination, the easiest formula is R of equivalent is equal to the multiplication of 2 resistance divided by the addition of 2 resistance. If the resistances or I can say resistors, basically the resistance or the resistors, we mean that the magnitude or the value. Okay, so the 2 resistors are Ri and Rj. So the multiplication, that means Ri into Rj, and the addition is Ri plus Rj. So this is the simple formula for 2 resistors. So whenever you are encountered with so many resistors that are in parallel, first make sure that you have to make pair of 2 resistance or resistors which can be used to determine for determining the equivalent resistance using that shortcut formula. So in that case, if anyone asks you to calculate the value of I1, that means the current that is flowing through R1, so what we will do, that we need equivalent resistance of R2 and R3. That means R2 and R3 we can make them a pair, right? First of all, we'll calculate the equivalent resistance of R2 and R3. Okay, that should be, so let us consider that equivalent resistance. I am not writing everything. Equivalent resistance of R2 and R3. It should be, let us think that this is R of A. That is, no, sorry, I can write RT. RT means R totals. So this is R of T or RT. That is the multiplication of R2 and R3 divided by the addition R2 plus R3. So now using the generalized formula. So what is the generalized formula? If we want to calculate the Rx, the opposite total should be in the numerator, and in the denominator there should be that resistance plus the opposite total resistance into total current. So in that case, if we want to calculate the value of I1, so we can write using the generalized formula I1 equals, in the numerator there should be the opposite total resistance, that means RT, and divided by that resistance, that means R1 plus opposite resistance RT into total current. So we can write, so RT means R2 into R3 divided by R2 plus R3, that means R1 plus R2 into R3, so divided by R2 plus R3 into total current I. So in that way, so we can calculate the value of I1. Similarly, we can calculate the value of I2. Okay. For calculating the value of I2, the total resistance should be R1 into R3. We will make a pair of R1 and R2, right? If we want to calculate the current I3, so we'll have to make a pair of R1 and R2. In that case, or in that following that formula, we can calculate any currents that is flowing through a particular resistors that are in parallel with other resistors. So the generalized formula is, once again I'm saying that I of x or Ix equals R of opposite totals. That means if we want to calculate the value of I1 that is flowing through R1, leave it for a while, calculate the total resistance of other resistors. Okay, after calculating this, calculating the total resistance of other resistors, we will have to plug the values in that generalized formula, right? So write down the formula. I'll upload some maths regarding CDR, VDR and every other stuff after finishing the theory. If you have any kind of questions, you can comment below. Thumbs up if you like, or if you have any kind of problem, so you can contact me in our Facebook inbox. So our Facebook page name is Metacentric, so you can message me. Thank you so much for watching this video. Share it with your friends.